Hello everyone. Welcome back to our another tutorial video. Now in this video, we will be discussing all about transistors. Okay, and if you will be watching this video until the very end, these are the following things that you can learn. First is we will be discussing on the few history about transistors. We will be discussing about the different parts of transistors, the different principle of the transistors. We will be also talking on how to test transistors, how to identify if the transistor is in good condition or it is defective that needs to be replaced. And in this video also, you will learn on how to identify the base, collector, and emitter leg of your transistor. And you will also learn on how to identify if the transistor given is NPN or a PNP transistor. Okay, if you want to learn all of those, you have to watch until the very end. Yes, and if you find this video useful, please do not forget to like and subscribe. Yes, thank you ahead. So we will start. So transistors is considered as the building blocks of all electronics world. It's because every microchips, every integrated circuit is composed of a transistors. So it means the transistor plays a very important role in electronics world. That is why it is being considered as the building blocks of electronics world. When we talk about building blocks, it means that is the foundation of every integrated circuit or the microchips that we have nowadays. Its foundation is its basic structure is a transistor. Okay, to start with, we will have first a small glance on the history about transistors. So we get in here. In 1906, an American inventor and a physicist, Lee DeForest, made a vacuum tube. He called it as triode or ardian. That is what he called his invention. And this transistor on that time is used mainly for the radios, and it is also used for the early computers because our early computers is actually having this bigger part. It has a vacuum tubes, and that is our previous computers. Unlike nowadays that our computers are very advanced in our technology, so it can be downloaded with different application. It can perform different tasks. Yes, and that's how fast is the evolution of electronics. Okay, so in the next part, have been here in 1947. It is discovered by, or it is presented by the John Barden and Walter Brattain. So this first transistor device, they call it as a point contact. Yes, this is the picture here. And above this picture is Mr. John Barden, and below is Walter Brattain. So this is Walter Brattain. Okay, I hope that is clear to everyone. And next is we have the uh, Moore's law. Moore's law is, it is actually his observation. So the complete name of Morris is Gordon A. Murray, in which he predicted that the number of transistors inside the integrated circuit could be doubled every 24 months or every after 2 years. Now, this Moore's law is very known for its prediction because it really happens, and he is one also of the co-founder of the Intel Corporation. Intel is one of the computer that we have now. For example, we have AMD, AMD series. We also have Intel series, G series, something like that. Yeah, do not be confused. So that is one of the contribution of this man towards the history of a transistor. Okay, so we got in here the definition of transistor. So transistor is an electronic device made of three layers of semiconductor materials that can act as insulator and a conductor. So it means transistor is one of the semiconductor device that we have in electronics. It is being mentioned here. It is composed of three layers of semiconductor materials that can, this is very important, that can act as insulator and a conductor. So I already mentioned this on the previous video and what is semiconductor. So if you are not familiar with semiconductor, please go to or go watch my previous tutorial video, and I discussed this was I discussed there. I discussed there what is semiconductor. So please try to look at it so that you will learn what is the semiconductor. Okay. The next definition. We have in here the three layers transistor is known as the bipolar junction transistor. That is the three layered transistors. It is also known as a bipolar transistor. To be specific, in this video, we will focus on the bipolar junction transistor. Yes, because if we will discuss all different types of transistor, we need lots of time. Yes, so in this video only, we will be focusing on the bipolar junction transistor. Okay, so I hope that is clear. So we got in here bipolar junction transistor, or the shortcut for that is BJT. Okay, the term bipolar refers to the use of both holes and electrons such as charge carriers in a transistor structure. Okay, now there are two types of bipolar junction transistor. We have the NPN and the PNP. So these are the two types of bipolar junction transistor. Okay, so to discuss more about NPN and PNP, so we get in here. This is our schematic symbol. This is schematic symbol for NPN transistor, and this is for the schematic symbol for our PNP transistor. The difference between these two, if you try to look at, this is the three legs. There are three parts of a transistor, or three leads. We call it as collector, base, and emitter. Okay, usually the base is the common terminal, while the collector collect currents to transmit it towards emitter. Anyway, it depends on different connection of your transistor in the circuit. So we get in here, this is our symbol. The part of the symbol that has an arrowhead, that is, we call it as the emitter. So let's try to look at. So in this NPN transistor, the arrow is here, the arrowhead is here. So it means this is our emitter leg. On the other hand, in the NPN, the arrowhead is here connected to this line in here. So it means this is the emitter. And then the base also is the part of this symbol that would form a little bit letter T. Yes, this the tail of letter T in this schematic diagram would be our base. The same on the other side also. And the opposite leg, which do not have the arrowhead, that is what we call as the collector. So it means Upon looking on the symbol itself, you can identify which leg, which part of this diagram is the emitter, the collector, and the base. So that would be your bases. Now you have to bear in your mind also that where does the arrow pointed, that should be the direction of the current also on your transistor. So your transistor will allow the current to flow in that direction. The same in here since the arrowhead is here. So it means your current must be flowing from the collector towards the emitter. And here also in the PNP, the emitter is on top, and then the arrowhead is pointing inside. Then the current will be flowing from emitter towards the collector. And the current will flow only in these two directions, when the base will have enough current only, because if it has more than or less than, it will not allow the current to flow in this direction. Well, anyway, it depends on its orientation in the circuit. Okay, now to help you remember what is NPN and PNP, so we have here a memory aid to guide you on how to remember the symbol of these different types of bipolar junction transistor. We have here letter N for, this is for NPN. The first N is never, the P is point, another N is in. So it means never point in. So you have in here, this is our NPN. So the arrowhead in here, that's our clue. The arrowhead never points in. That is why it is called NPN. So never points in. So the symbol itself, it will tell you what type of transistor because of this memory aid that we have. It means if upon looking up on the symbol, if the arrowhead is not pointing in, then that is referring to never point in. Okay. So how about on the NPN? So our one of our memory aid, we use this for you to recall it easily. So we have in here PNP. This referring to point in permanently. So if you try to look at the in-pin symbol, the arrowhead is pointing inside. You might be asking, sir, how about if the arrowhead is found here below, then it will be pointing inside. Then the emitter will be found on the other side. The same way, it is still called PNP because the arrowhead is pointing in permanently. It is always pointing inside. Then it is called PNP transistor. Okay, I hope that is clear to everyone. If you have questions, do not forget to write a comment below so that I can also look at your questions. I can find an answer to it. I don't worry, I will not leave any questions unattended. I will be catering your needs because this is one of the purpose why this video is made, for the student to understand this easily. Yes, if you have other ways on how to uh, have a clue or how to have a memory aid, so you can actually replace this word in here. So this is just my information on how to help you, but if you have another, then it doesn't matter because our main purpose is for you to recall. Yes, no problem with it. So we will not have an argument on that. Okay, next part. This is our basic construction, the basic construction of a transistor. So inside the body of a transistor, it would look like this. The base is found at the center. The same in NPN as well as the PNP. But to remind you, in actual construction, in actual transistor, it is not always that the base is found at the center. There are times that the base is found at this, it's either on the left side or on the right side. what we are trying to express here is the inner construction. It is always that the base is inside. But when it's in actual transistor, it is not always that the center leg would be the base. So I hope that is clear. Okay. A transistor has three dope region for both types. That is, the base is a narrow region and sandwiched between the larger collector and emitter. So it means the base is a smaller portion. It is being trapped between the emitter and the collector. And the part which has the bigger occupation on the structure, I mean, yes, the bigger part on the structure is the collector. Yes, it is the collector, and then followed by the emitter. And the smallest part is the base. It's either the base is positive or negative, it doesn't matter. But as long as the base on the construction, the real construction, it is the smallest part on the diode construction. Okay? So, next is the same in here. As what I mentioned, there are three dopes. Yeah, we have the emitter region is heavily doped, and its job is to emit carriers into the base. That's the work of the emitter region. The base region is very thin, so it means it is small based on this illustration here, and lightly doped. So most of the current carriers ejected by the base pass through the collector. So when emitter give drop the current towards the base will pass this current towards the collector. Okay. And lastly, we have the collector region it is moderately doped, and it is the largest of all three regions. So again, the largest of all these three regions is the collector, that's followed by the emitter, and the smallest region is the base. So I hope that is clear. So next is we have here the three LEDs of transistor. So or the three region, we call this three regions. So we have the emitter, base, and collector. So if this is our actual picture of a transistor, if this labeled as 1, 2, 3, so it means this is the terminal 1, terminal 2, and 3. So if terminal 1 is the emitter, terminal 2 is the base, and terminal 3 is the collector. So if you try to look at in this structure, it means that the center leg would be our base. But again, let me recall, it is not always that the center leg would be the base, because there are times that the pin 1, this labeled as number 1 in here, can be the base, or the pin 3 can be the base also. That is why if you will be given with the transistor, one of your problem is to identify where is the collector, base, and the emitter terminal of the transistor. Unless you have the internet, then you can browse on the internet the specification. You can type the specification of the transistor, then it will eventually provide you which leg is the emitter and which leg is the base and the collector. But of course, in the real life scenario, if you are working on the troubleshooting, you can no longer, or if you do not have internet, then that is very important for you to know on how to identify the base, collector, emitter, including to identify the condition of a transistor. That is why this video is made for that purpose. So I hope you can learn those upon watching this video. So next, we have here, we also have the transistor's configuration. It means how the transistor is connected towards the circuit. So actually, we have, I guess, three in here. So we'll start from number 1. So number 1 is common collector. So the input signal is applied to the base terminal, and the output is taken from the emitter terminal. And the collector terminal is common to the input and the output. So based on this illustration, The collector is connected towards the ground, and it is paired with the input, which is the base. So the base is connected with a certain value, while the C is connected towards the ground. And our output in here is the emitter, and of course the collector. So it means the common in here is the collector. This is for our input, base, and collector, and our output in here is the emitter and the collector. Okay, I hope that is clear. That's how this transistor is connected towards the circuit. That is why it's called common collector, because the collector is common between the input and the output. Okay, so next is we have the common base. So the base now is shared between the input and the output. So we get in here, for example, if the input is the emitter and the base. So it means the emitter would be supplied with a specific value of current, while the base would be connected towards the ground. And the output is the collector and the base. So it means the base here would be connected towards the ground, and or it is our ground terminal, and the collector would be our uh, source with a specific value. So that is what is being imposed on the common base configuration. Okay, that is the common base configuration. Next, we have the common emitter configuration, mostly applied in the practical amplifier circuit, since it provides good voltage, current, and power gain. So this type of connection is used on the amplifier circuit. And talk about amplifier is to gain, is to have more power. For example, we also call this one as a power multiplier. Yes, because we are gaining power towards the output. Okay, so in the common emitter, it means the emitter is connected towards the ground, and the base and the emitter will become our input, which is the emitter becomes the common, and the output will become the collector and the emitter. And that is how we configure, how we connect our transistor in the circuit if we are having common emitter configuration. Okay, I hope that is clear. So next part in here, we have the characteristic of the configuration of a transistor. So the output, these are the output characteristic. So the first one, you have the saturation or saturation region, in which both junctions are connected in bias. I mean forward bias. And the input, I mean the current in the collector increases linearly with the voltage on the collector and the emitter. So it means once the current on the collector is increased, then linearly, it means the same time, the voltage on the collector and the emitter will also increase. That is what is being specified in here. And next, we have cutoff region where both junctions are reverse bias. So it means the current on the base is very small and essentially no current flows on the collector. So it means uh, the base doesn't have enough current. So that is why it could not allow the current to flow from collector. And the current from collector is essentially zero with increasing voltage on the collector or emitter. So if you have either a higher amount or a certain voltage on the collector or on the emitter, when the base doesn't have enough current, then current could not flow towards the collector towards emitter, or emitter from emitter towards collector. So there is no flow of current because the base has a very small amount of current, which is not enough to trigger the voltage, I mean the current to flow whether from collector to emitter or emitter to collector. Okay, because that is actually vice versa. Okay, next we have here active region. Active region in which the transistor can act as a linear amplifier. So amplifier is to gain power to double current. double the power. Okay, that is what we are referring to. Amplifier is to have a gain in power. Okay, wherein the base and emitter junction is in forward bias, and the base and the collector junction is reverse bias. So the current in collector increases drastically through only small changes in the current of the base. So this part in here, though you only provide small amount of current on the base, what will go towards your collector is a little bit higher. So there is a multiplication of the amount of current. So in that case, your transistor act as an active device. So it's performing its amplifier principle. And lastly, number 4, you have saturation and cutoff regions, areas where transistor can operate as a switch. Yes, when there is enough amount of voltage on or current on the base, then your transistor can act as an on switch. It means that is to close the circuit. But if the current is not enough on the base, then your transistor can act as a switch that cut the flow of current. So that is open switch. But if there is enough current on the base, your transistor will act as a closed circuit. It will close the circuit on your circuit design. So that's how saturation and cutoff regions works on. So it acts like a switch that is to, because the main purpose of the switch is to turn on and off. Okay, so I hope that is clear to everyone. The next part we have here, the testing a transistor with the ohmmeter. So how to test transistor with the ohmmeter. Now we discussed this in the previous video on how to test diode using ohmmeter. Now the same thing in here, because if this is our transistor, for example, the transistor in reality can be compared into two diodes which are connected in, it's either it's positive to positive or negative to negative depending on the type of transistor that we have. So if this is our transistor, this is never point in this NPN transistor. Yes, it means NPN. It means the base will be positive. Can be illustrated this way as a diode. Okay, if you use two diodes, it would look like this. It means the two positive of this diode are connected. That is considered as our base. And the other end of the diode would be our emitter, and the other end would be our collector. So it means we can check transistor using ohmmeter. Okay, so have more discussion on that. We have in here. So this is our testing of transistors with an ohmmeter. So of course, before testing, I suggest, but of course, it depends on how you do it or in your daily practice. But based on my practice, I'll be setting up my multimeter into times 10, just the same as what you can see in here. And then I need also to, of course, after setting your multimeter into ohmmeter times 10, you need to set needle pointer exactly on 0. So it should be in 0 ohm. And then I need to make a table because this is for the beginners. But if you are already on this kind of work, then there's no need for you to make the table. But for the students to be guided, for others to be guided, I need to have a table. The first column in here, I have the measuring point. I'm referring to the combination of the leg of a transistor. So if I'll label this one as terminal 1, 2, and 3. So this is pin 1, pin 2, and 3. So it means the combination in here, when I say 1 and 2, it means I am connecting my test proof of my multi-tester into pin number 1 and pin number 2. The color here of this pin number is referring to the color of our test proofs that is connected to the specific terminal, specific leg of our transistor. Now, To just a reminder, no, you do not forget that when you use your analog multimeter in semiconductor materials, you have diodes and this transistor in here. It means that the black test probe will become positive and the red test probe is our negative. Okay, I hope that is clear. So if I'll check or if I'll place my test probe this way, the black test probe is pin 1, the red test probe in pin 2, and if I can get 45 ohms, so based on this reading, I have here this 4.5 and that is multiplied by 10, it will become 45 ohms. Okay, so I need to record the data in here. So this is the result of this testing. So I get in here 45 ohms. I need to record it because I will leave it there, then proceed to the next task. So the next part is we have the other combination. So we use pin number 1 and number 3. And if this is the reading of my multimeter after connecting my test probe this way, if it is infinite, it means the needle pointer does not move at all. So I need to write here as the result of infinite. Yes, whatever I get in here in testing, I will just be placing it here. Yes. You have to place it here honestly. Yes, because that will help you identify what type of transistor, what is the condition of transistor, which leg is the base, which leg is the emitter and the collector. Okay, so next combination of leg. So you have 2 1s. It means the black test probe now will go in terminal 2 and the red test probe will go in terminal 1. So if I can still get infinite, the same thing, I need to record, then proceed to the next combination, which is 2 and 3. So it should be this way. So pin number 2 is on black test probe and pin number 3 is on red test probe. So if I still get infinite, it's fine. I'll just going to record it and continue with the other combination. So we have the next combination is 3 and 1. So it means 3 terminal pin number 3 is connected towards the black test probe. Yes, we get in here. And pin number 1 is connected to red test probe in this illustration. If I can still get infinite, all I need to do, whatever is the reading that I can get in here, I need to record it on the result. Okay, so we only have here the last one. We have the 3 and 2. So this is the connection. So this is terminal 2 is connected towards the red test probe. And terminal 3 is connected towards the black test probe. If I can get the reading like this is just an example, okay? So it means I got here 55 ohms because this is 5.5 multiplied by 10. I get 55 ohms more or less. So these are now the data on my table with the corresponding combination of measuring point. Okay, now this data is very important to know the condition of the transistor. To know also which leg is the base collector emitter and what type of transistor that I have. Is it NPN or is it PNP? Okay, so this is my basis, this data table. So to start with, I got in here. So we have identifying the condition of a transistor. Now, we will start first on the good condition. So there are things to remember. So when can you say that the condition of your transistor is good? The first one is there must be two readings. There must be two reading value in which not 0 ohm and the rest must be infinite. So there must only be two readings, resistance reading. So going back on our table, so there are two readings. So that's eventually saying that the first statement here is correct. Then three terminals involved. It means terminal 1, 2, 3 should be there. So let's try. Of course, it's referring to the part where you can get the two readings. So let's try to check. The first reading is we have the terminal 1 and 2. Then the second reading we have terminal 3 and 2. So it means there are three terminals involved. The terminal 1 is here, terminal 2 is here, terminal 3 is here. Okay, so it means three terminals involved. That's true. The second part is correct. Then common terminal must have the same polarity. So it means going back to the two readings. So which terminal here or which leg is common? We have that 2 because the first value that we have in here 1 and 2. The second reading is 3 and 2. It means the common in here, the common leg or the common terminal is 2. But what is being specified? Common terminal must have the same polarity. Let's try. Yes, terminal 2 here in these two readings is both connected towards the red dash probe. So it means it has one polarity. So that makes this statement here correct. And then lastly, two different resistance reading value. So let's try going back. So these are our two readings. Are they different to one another? The answer is yes. So most probably, this transistor is in good condition. Okay? So that's the thing that you need to consider. So next, this is our example. This is our this is our findings based on that table. So this is the data table that we get on the testing that we had the previous slide. So the condition in this transistor, as what I said, is good. Yes. And our problem is which terminal is considered base, collector, and emitter. So I already have here an answer. We need to justify why we consider terminal 2 as the base. So the base terminal is the common terminal. Okay, I'm referring to the both reading in here. So there are two readings. Okay, so common terminal of these two readings is terminal 2. So it means that is the base. And then the collector terminal is the partner of the base terminal that has the highest resistance value. So which one? So this is 45, this is 55. This is 2 and 1, this is 2 and 3. So it means terminal 3 would be our collector because it is having the highest resistance value. Okay? Now terminal 3 would be our collector. And the other leg would be our emitter. So the terminal 1 would be our emitter. Now next is what type of transistor? Is it NPN or PNP? Now, as what I said, analog multimeter, if it is used in semiconductor, the red test probe becomes negative, correct? Okay. Now, since pin number 2 is connected towards red and this is considered negative, this pin number 1 is positive and pin number 3 also is positive. So we have here a type of transistor which is this again positive. This P, the base is negative. So we have here the type of transistor that we have is PNP. Okay, I hope that is clear. This PNP. This is the type of transistor that we have based on this data table that we have. Okay, I hope that is clear. If you have questions, do not forget to comment down. Okay. So next, we have another possible condition. So defective undershorted when it has one or more 0 ohm resistance reading. So once there is even one reading that will give you 0 ohm, then your transistor is defective undershorted. Okay. The next possible defect could be open. Yes. When can you say that it is open? When there is only one resistance reading and the rest of the reading is infinite, then the condition of your transistor is open. If there's only one and the rest is infinite, or all of the readings are infinite, then the condition is defective and they're open. Okay, so let's try to have, this is the example of defective shorted. So again, one or more 0 ohm resistance reading. So based on this data, there are more than 2 readings in here. and we get in here the 0 ohm, automatically the condition is defective under shorted. And the question is, which leg is the base collector and emitter now, and as well as what type of transistor. Now, when the transistor is defective, you cannot identify what type of transistor. Yes, of course, you can identify by testing. But if you're going to search it, then you can identify what type of transistor, but it is defective. Okay, but if you're going to use instrument, if the transistor is defective, you could not identify which leg is the base, which leg is the collector, and which leg is the emitter. At the same time, you could not identify what type of transistor. Okay, I hope that is clear. So again, based on this data that we have in here, the condition of this transistor must be defective, undershorted, and we cannot identify what type of transistor. At the same time, we cannot identify which leg is the base collector and emitter by testing alone. Okay, I hope that is clear. Next, we have here, this is our example of the defective open. So when one resistance reading or all are infinite. So for example, in here, we only have one resistance reading, the rest are infinite. Then we consider this as open. Why? Because there is no other connection to the other part of your transistor. Now, at the same time, since it is defective, we cannot identify which leg is the base, which leg is the collector, and which leg is the emitter. At the same time, you could not identify also what type of transistor do we have. Okay, because again, the condition of the transistor is defective. So I hope that is clear. Next, we have here defective under leaky. So if it is leaky, then these are the condition. Two resistance reading or more, which is not equal to 0. So there might be instances that there are only two readings, but then there's no common terminal or three or more terminals involved. So it could be three or more terminals involved. But the problem is no common, the common terminal does not have one polarity. So it means the polarity of the common terminal is positive and negative. So it means it's not only one. So it means it is defective under leaky. So let's see, for example, based on this data in here, this is actually more or less can be considered as good because there are only two readings. Yes, two resistance reading, but this can be also defective under leaky because there are two readings. Then the second is three or more terminals involved. How many terminals are involved in here? We have two. This terminal 2, terminal 3. Below, in this reading, we have terminal 3 and 2. So it means only two terminals are involved, only terminal 2 and 3. So we do not have terminal 1 in here. And that makes this data as defective under leaky. Okay, because only how many two terminals involved. So it can be three or two terminals involved. Okay, and then the condition is defective under leaky, and we cannot identify base, collector, emitter, as well as what type of transistor, because again, the condition of your transistor is defective under leaky. Okay, and that's how you are going to test transistors using ohmmeter. So I hope this video will help you. If you find this video helpful to you, do not forget to like and subscribe. Okay, thank you so much for watching. See you on the next tutorial video. Uh, See you next